In the circuit shown, the breakdown voltage and the maximum current of the Zener diode are 20 volts and 60 milliamperes respectively. So let's make a note here that the Zener breakdown voltage is 20 volts and the maximum current that can flow in the breakdown, that is IZ max, is equal to 60 milliamperes. Now the values of R1 and RL are 200 ohms. R1 is 200 ohms and RL is 1 kilo ohms respectively. What is the range of VI that will maintain the Zener diode in the on state? So when we look at Zener diode characteristics, obviously in the reverse bias where our interest is, it enters into breakdown region. When it enters into breakdown region, that's when we say the Zener diode is in on condition. As the series resistance is not given for the Zener diode, we're going to take that Zener resistance RZ is 0. And we take this is Vset. This is the equivalent circuit model for the Zener diode in the breakdown region. Whereas when we look at the Zener diode in the off region, this region is off. In that region, the Zener diode is considered to be an open circuit because the current that is flowing through is negligible. Now, in order to get into on region, that is this region, first of all, the Zener diode has to go through the off region. So when the Zener diode is in off state, as it is open circuit, till the voltage across the Zener diode becomes 20 volts, which is the breakdown voltage, the Zener diode would be open circuit, which means as the V in keeps increasing, we hit a point of V in such that we come to a point of 20 volts. Till that point, the Zener diode is open circuit, as shown here. So let me draw the equivalent circuit here, that we have R1 and the Zener diode is shown open circuit here, and then we have the load resistor RL. Now the voltage across the Zener diode here, which is nothing but the voltage across the load resistor corresponding to a particular V in. So let's find what is this voltage. That voltage we have, which is across the Zener diode, is equal to RL over RL plus R1 times VI, which is equal to RL is 1 kilo ohms, which is 1000 ohms, divided by RL plus R1. R1 is 200 ohms, RL is 1000 ohms, it becomes 1200 ohms, and we have VI. What should this voltage be? This voltage should hit 20 volts so that we will enter the breakdown region. Just before entering the breakdown region, we are open circuit here. The Zener diode is open circuit. So let's make this voltage is equal to 20 volts to find out what is the minimum voltage of input to make sure the Zener diode enters breakdown. So let's find that VI, so the minimum voltage is equal to 12 by 10, these two cancel, times 20. So this will be 24 volts. Now once we make sure that the input voltage is greater than 24 volts, now we need to find what is the maximum input voltage till which the Zener diode is kept in the region of operation, which is in the breakdown region. We are given that the maximum current that the Zener diode can accommodate is somewhere here, that is 60 milliamperes. So let's find that out. For the second case, let me take the circuit diagram where the Zener diode has entered into breakdown region, where it acts as a voltage reference, where the voltage across the Zener diode would be 20 volts, and the input maximum, let's say we are applying the maximum input voltage at which the current that is flowing through the Zener diode should be equal to 60 milliamperes. And we can figure out what is the current flowing through the load resistor, because the voltage across the Zener diode would be 20 volts. Hence, even the voltage across the load resistor would be 20 volts. So the current flowing through the load resistor, IL, will be equal to 20 volts divided by 1 kilo ohms, which is RL. So this will be 20 milliamperes. So the total current flowing through the current limiting resistor, which is R1, is 60 milliamperes plus 20 milliamperes, which is 80 milliamperes. Now the input voltage maximum will be equal to the voltage across the current limiting resistor plus the voltage across the Zener diode. So voltage across the resistor R1 is 200 ohms times 80 milliamperes plus the voltage across the Zener diode is 20 volts. So this will be equal to the maximum input voltage, which can keep the Zener diode within the range. So this is equal to 16 volts plus 20 volts. This is 36 volts. So we can say that the input voltage should be in between 24 volts to 36 volts. So the answer is option B. If you like the video, give a thumbs up. If you haven't subscribed yet, please do subscribe, and thank you for watching.